Especially excited about what you and I are going to solve about today. You are the person who made the time to listen to this, and this means that you are interested in learning about the ways that you can improve your solving skills. Thank you for taking this time to listen because your learning is going to get better. And also, thank you for taking the time to share this video with the people that you know pretty well. So, you will embrace the simple truth that you're fully capable of solving any problem of this kind ahead. Today's topic is from eigenvalues and eigenvectors, and I'm going to discuss a problem related to Cayley-Hamilton theorem. As this is the most important, let's focus on this video. So first we have to verify Cayley-Hamilton theorem. A is equal to 2, 1, 2, 5, 3, 3, minus 1, 0, minus 2, and again we have to find A inverse. So how to verify this Cayley-Hamilton theorem? So the statement states that every square matrix satisfies its characteristic equation. First of all, we have to find the characteristic equation of this matrix A. See here, the characteristic equation is nothing but A minus lambda I is equal to 0. So this is the A matrix, square matrix, the question, minus lambda into I. I means 1, 0, 0, 0, 1, 0, 0, 0, 1. So if I multiply, see here will be lambda 0, 0, 0 lambda 0 and 0, 0 lambda. So in place of diagonal elements, so lambda is replaced. So if I subtract, see here in place of diagonal elements, I am going to subtract lambda. That is 2 minus lambda, 3 minus lambda, minus 2 minus lambda. The rest, the remaining values are as usual. That is 1, 2, 3 is same, and 5 minus 1, 0 are same here. So this will be the characteristic equation if you solve this one. So here the first thing here is if I take this one. So here this is 2 minus lambda if I take. So this will be 2 minus lambda into. So here we have to close the row and column. So we have to multiply these two. So this will be 3 minus lambda into minus 2 minus lambda minus 3 zeros are 0. Clear? And next one, if I take the middle one, so we have to add minus. So this is minus 1 times of. Now we have to close the row and column. So these two should be multiplied. That is 5 into minus 2 minus lambda. This is minus of minus. This value is plus 3. And the next one, the third term here is, this value is 2. So here this will be 2 times of, see here this will be 2 times of. Now if I close this row and column, so now we have to multiply this one 0, and this is minus of minus plus, this will be 3 minus lambda is equal to 0. Clear? See here 2 minus lambda, so we have to close row and column, we have to multiply AD minus BC, and next one minus 1 times of, you have to close row and column, so we have to multiply these two, and plus 2 times of, so we have to multiply these two. See, if I keep on multiplying, so this will be 2 minus lambda times of. So if I multiply these two, this will be minus 6 minus 3 lambda, and this is plus 2 lambda plus. So if I multiply this will be lambda square. Clear? This is minus times of. If I multiply this will be minus 10 minus 5 lambda plus 3. Clear? And this is 2 times of, this is 3 minus lambda is equal to 0. And if you observe this one, this is 2 minus lambda times of. So here this is lambda square. Minus 3 lambda plus 2 lambda is minus lambda. This is minus 6 minus. So here this is minus 5 lambda. Minus 10 plus 3 is nothing but minus 7 plus 2 times of, this is 3 minus lambda is equal to 0. If I multiply with 2, this will be 2 lambda square minus 2 lambda minus 12. So if I multiply with minus lambda, so this will be minus lambda cube. Minus into minus plus, this is lambda square. This value is plus 6 lambda. And if I multiply, this will be plus 5 lambda plus 7. So 2 3s are 6 minus 2 lambda is equal to 0. Now see here, there is only single lambda cube here. Minus lambda cube is a single. So here I am writing minus lambda cube. Clear? And the next thing here is I am going with the quotients of lambda square. This is 2 lambda square. So if I go, this is lambda square. That is 2 plus 3. So 2 plus 1. So this is 3 lambda square. Clear? And the next one, if I go with the lambda quotients, this is 2 lambda. So if I go like this, so this is lambda and this is lambda. See, if I add all this, that is 6 minus 2 is 4. 4 plus 5, 9. 9 minus 2 is 7. So this will be plus 7 lambda. Clear? This will be 7 lambda, and see if you observe this one, constants remained. So this is minus 12 plus 7 plus 3. Clear? So this is 13 minus 12 is plus 1. So this will be our characteristic equation. So here this will be the characteristic equation. So we have to check whether our square matrix, our question satisfies the square characteristic equation or not. So we have to replace the square matrix in place of the characteristic equation as minus a cube plus 3a square plus 7a plus 1. If this is going to become 0, then we say that every square matrix satisfies the characteristic equation. So this is our characteristic equation. So this is our characteristic equation. See here. Now, in order to substitute, we need to find out the value of a cube, a square and a. For that, see here. So now I am going to substitute here a cube value. So this is a cube plus 3a square plus 7a plus 1. Clear? Now, so I am going to find out the value of a cube, a square, a. A is already given here. So for first of all, we have to find a square. So for a square, this will be a into a. So a square value is equal to, so this is 2, 1, 2. This is 5, 3, 3. This is minus 1, 0, minus 2. For 2 times if I write, this will be a square. That is 2, 1, 2. This is 5, 3, 3. This is minus 1, 0. This is minus 2. For multiplication, so here, so for clarity, I am keeping the lines here. So here, let me multiply. So a square value will be, so if I multiply, this is 2 into 2, this is 4. And this is 1 into 5, this is 5. And 2 into minus 2 is minus 2. 2 ones are 2. 3 into 1, 1 into 3 is 3. 2 into 0, this value is 0. So this is 2 2s are 4. And 1 into 3 is 3. And this is going to become minus 4. Clear? 5 2s 10. 3 5s are 15. And 3 into minus 1 is minus 3. So 5 1s are 5. 3 3s are 9. And this is going to become 0. So this is 10. And next thing here is, so this value is plus 9. Clear? This value is going to become plus 9. A square, this is going to become plus 9. And this is going to become minus 6. Clear? And the next one, minus 2. This is 0. Minus 2 into minus 1. So this value is plus 2. So this is going to become minus 1 plus 0. Minus 2 into 0 is 0. And this is going to become minus 2. And this value is going to become plus 2. And this is going to become plus 4. So here our a square value is very clear as, so this is 9 minus 2. This value is a 7. This value is 5. So if I cancel, so this is a 3. And this value is, see here, this is 25 minus 3. The value here is 22. So this is going to become 14 and 19 minus 3. So here this will be 13. And if I cancel, this value is 0. So this is minus 2 and 4 minus 2 is 2. So our a square value is ready. And this time I'm going to find out a cube value. So a cube is also needed. For finding a cube, it is so simple. So this is a square into a. So what is our a square value? A square value is also very clear. So a cube value is equal to, what is our a square? This is 753. This is 22. This is 14. This is 13. This is 0, minus 1, 2. And what is our a? The question here is a is very easy. That is from the question. That is 2, 1, 2. This is 5, 3, 3. This is minus 1, 0. This is minus 2. So we'll be getting a cube if I multiply these two. So here every time I do like this. So for easy evaluation, see here, a cube value is very easy to calculate. That is 7 2s are 14 plus 5 5s are, this value is 25. And this is going to become minus 3. This is 7. So this value is going to become 15. And this is going to become 0. 7 2s are 14. And this is 5 3s are 15. And this is going to become minus 6. Clear? 22 2s are, the value here is 44. Plus 14 5s are 70. And this is minus 13. Clear? This is 22. And this is going to become 42. And this is going to become 0. 22 twos are, this value is 44, and this is going to become again 42, and this is going to become minus 26. 0 into 2 is 0. This is minus 5 and this is minus 2. So this is going to become 0. This is minus 3 plus 0. So this is going to become 0, minus 3, and this is minus 4. Clear? And therefore, so if I add all these, so this will be 39. So here 39 minus 3, so this is going to become 22. This is going to become 29 minus 6, and if I add these two, this will be 114. So this is 14 minus 13, and this is going to become 64, and this is going to become 86. So this is 86 minus 26, and this is minus 7, this is minus 3, and this is minus 7. So we got a cube value as, so this is 36, this value is 22, this value is 23, and this value is going to become 101, this is a 64, and this value is a 60, this is minus 7, minus 3, minus 7. So we got a cube value as well as a square value. A value is also ready. So here, so if I substitute, so before going to substitute, I'm writing at one place, that is 36, this is 22, this is 23. So this is 101, this value is 64, this is 60. This is minus 7, minus 3, minus 7. So what is our a square value? So a square value, I'll show you. So this is a 7, so this value is a 753. This is 22, 14, 13, and this is 0, minus 1, 2. And what is our a value? So a value is from the question, that is 212. Clear? This is 212. This is 533. This is minus 1, 0, minus 2. Now here we have to check whether the square matrix satisfies the characteristic equation or not. See here. So if I substitute here in this equation, so this is going to become minus a cube. This is minus a cube plus 3a square plus 7a plus 1. And see, this is going to become, what is a cube here? This is 36, 22, 23. This is 101. This value is 64. This is 60, minus 7, minus 3, minus 7. Plus 3 times of a square. So this is a 7, 5, 3. This is 22, 14, 13, 0, minus 1, 2. Plus 7 times of a value. This is 2, 1, 2. This is 5, 3, 3. This is minus 1, 0, minus 2. Plus I value is nothing but 1, 0, 0, 0, 1, 0, 0, 0, 1. Clear? Now if it's going to become 0, then our Cayley-Hamilton theorem is satisfied. Now I am going to multiply with minus inside. So this is going to become minus 36, minus 22, minus 23, minus 101, minus 64, minus 60. This is plus 737. Clear? And now if I multiply with the 3 inside, this will be 21, 15, 9. So if I multiply, this will be 66. Clear? So this is going to become 42 and this is going to become 39. This is 0, minus 3, 6. And the next one here, if I multiply with 7, so this will be 14, 7, 14, 7 5s are, this value is 35, this is 21 and this is 21, this is minus 7, 0, this is minus 14. And here the value here will be 1, 0, 0, 0, 1, 0 and this is 0, 0, 1. Clear? Now I am going to write at one place. See, this is minus 36. So this is plus 21. So this is going to become 14 and this is going to become 1. Clear? This will be minus 22 plus 15 plus 7 plus 0. And this is minus 23 plus 9 plus 14 plus 0. Clear? And this is minus 101 plus, this value is a 66 plus 35 plus 0. And this is minus a 64 plus 42 plus 21 plus 1. So this is minus a 60 plus 39 plus 21 plus 0. So this is going to become 7 plus 0 minus 7 plus 0. So this is 3 minus 3 plus 0 plus 0. So this is a 7 plus a 6 minus 14 plus 1. So here, this is going to become, this is minus 36. If I add all these, this will be plus 36. This is minus 22 plus 22. So here, this will be minus 23 plus 23. So this is minus 101 plus 101. So this is minus 64 plus 64. So this is minus 60 plus 60. Clear? So this is 7 minus 7, this is 3 minus 3, and this value is nothing but 13 minus 13. So if I keep on cancelling all these values, so here if I cancel all these values, so what remained here? 0 0 0. So this will be 0 0 0 0 0 0 and 0 0 0. So what is our equation here? So this is minus a cube. So this is minus a cube plus 3a square plus 7a plus 1 is equal to 0. So this is nothing but the characteristic equation. So our characteristic equation is nothing but minus lambda square plus 3 lambda, sorry, minus lambda cube plus 3 lambda square plus 7 lambda plus 1 is equal to 0 is the characteristic equation. So here our square matrix, see here, square matrix, our square matrix satisfies the characteristic equation. So if it satisfies the characteristic equation, hence Cayley-Hamilton theorem is verified. So hence we can conclude that hence Cayley-Hamilton theorem is verified. So this is verified. Clear? So this is how we have to show that it is verified, and after verification part we have to find the A inverse. So this is most important. See here. So in this equation we got minus a cube plus 3a square plus 7a plus 1 we got as 0. So here from this Cayley-Hamilton theorem, so we have to multiply on both sides with A inverse. So if I multiply with A inverse on both sides, so this will be minus a cube. So this will be minus a cube plus this is 3a square plus 7a plus 1, and here this is 0. So from both sides I've multiplied with A inverse. So if I send it to inside, so this will be a cube into A inverse. This will be minus a square plus 3. A inverse into A is nothing but A. This is 7. So if I multiply, so this will be A inverse into A, and if I multiply, this value is A inverse and this value is 0. So here, so this is going to become A square plus 3A plus 7 into I plus A inverse is equal to 0. So here we need the value of A inverse. See, clear? We need the value of A inverse. For getting A inverse value, I am sending the other times all these terms to other side. So this will be plus A square minus 3A minus 7 into I. So we have all the values ready. A square is ready, A is ready. So A inverse value is, what is our A square value? So just now we found A square value is nothing but 7, 5, 3. This is 22, 14, 13, and this is 0, minus 1, 2. Minus 3 times of, what is our A value here? This is 2, 1, 2. This is 5, 3, 3. This is minus 1, 0, minus 2. See, after substituting A square value and A, so this is going to become 7 into I, 1, 0, 0, 0, 1, 0, 1, 0, 0, 1. Clear? So our A square value will be, so this value is 7, 5, 3. This is 22, 14. This value is 13, 0, minus 1, 2. Minus, so if I multiply with 3, this will be 6. 3 ones are 3, 6. So this is going to become 15, 9, 9. So this is minus 3, 0, minus 6. And if I send minus 7 inside, minus 7, 0, 0. 0, minus 7, 0. And this is going to become this one. So if I write it in one matrix, so this will be 7 minus 6 minus 7. This is 5 minus 3 plus 0. This is 3 minus 6 plus 0. And this is 22 minus 15 plus 0. And this value is 14 minus 9 minus 7. And this value is 13 minus 9 plus 0. And this is 0 plus 3 plus 0. And this is minus 1 minus 0 minus 0. And this is going to become 2. And this is plus 6. And this is minus 7. Clear? So A inverse value is very clear. If I cancel this one, minus 6 remain. 5 minus 3 is value is 2. And this is going to become minus 3. 22 minus 15 value is 7. So this is minus 16 plus 14. This is minus 2. And this value is plus 4. And this is 3. And this value is minus 1. 8 minus 7. The value here is 1. So this is how we have to solve A inverse after finding Cayley-Hamilton theorem verification. See here, as it is very simple and sure short question. So first of all, we have to verify. So we have to find out the characteristic equation from the diagonal elements. If I subtract my lambda, then after calculating, so I got this is the characteristic equation. So if I substitute our square matrix and see, and after calculating a cube a square value, see here, after calculating a cube and a square value, so a square is nothing but a into a cube is nothing but a square into a, and after getting our a cube, a square and a value, after substituting in the characteristic equation, so here it is satisfied. So we got the equation satisfied by the square matrix. Therefore every square matrix satisfies its characteristic equation. Hence Cayley-Hamilton theorem is verified. After verification, don't stop. See here, multiply both sides with A inverse, so we'll be getting A inverse here. So in order to find A inverse, we have to set these three terms to other side. So this will be A square minus 3A minus 7A. So we have already found a square value. A value is ready and I is known, everybody knows. And after substituting, so we got the final result as this. Thank you so much for watching, and if you really understand this one, please practice, and every problem of this kind is so simple to follow and only simple steps are there. So even though the video is lengthy, the concept is so easy. Definitely you can score more if you follow this video. If you really like, please pass it on to as many friends as you can. That is the greatest help needed to this channel. Thank you for staying till the end.